Alright, so good evening to everyone and welcome to another episode of Moyo. So we'll be looking at today vectors. Again, vectors is another key topic we see in the Csec examination, and students often have some challenges with vectors. So we'll be doing this evening some Csec practice questions on vectors, Csec past paper questions on vectors, understanding the two types of vector questions that we can see, one on the displacement vector and the other on the position vectors. So we want to ensure that we have some understanding and we can answer that question comfortably if it does come in the exam. Alright, so with that said everyone, don't forget to like, share and subscribe to Moyo. Alright, so with that said, let's get into it. So this evening we'll be looking at questions that will involve the displacement vectors, position vectors, the triangle law, polygon law, parallelogram law, calculating the magnitude of the vector quantity, equal vectors, parallel vectors, collinearity of vectors. Alright? So let's get into it. So it says here the diagram below shows quadrilateral, and this is quadrilateral, OLMN, as you see there on the diagram, in which O is the origin, OL, so vector OL, you know all vector quantities will have magnitude and direction. So you have here vector OL, whose magnitude is 4y. We have vector OM, whose magnitude is 6z. We have vector ON, whose magnitude is 2x. And it says here to give more information, the point A lies on LM such that LA to AM, so they often give you a ratio, is 1 to 2. And the point B on MN such that MB to BN is 2 to 1. So this is important information that is given. And let us apply our knowledge to the question shown. Now, what I like to do is to draw the diagram. So I will draw the diagram. This is OL, LM, MN, and we have ON. And of course, you have this line drawn from O to M. Yeah? So this is M, this is N, this is point B, this is the vector OM, whose magnitude is 6z. We have vector OL, whose magnitude is 4y. We have vector LM. And of course, we have A placed on LM such that LA to AM is 1 to 2, and you want to understand what 1 to 2 means. And of course, B is placed on MN such that BMB to BN is 2 to 1. You want to understand what that means as well, right? So let's make sure we have all the information. Of course, vector ON, the magnitude is 2x. So the question says, express in its simplest form vector Mn in terms of x and z. So they want us to find vector Mn in terms of x and z, meaning the answer for vector Mn, the magnitude of vector Mn, the answer must be in terms of x and z. Alright? So for us to find Mn, the first thing we want to do is to put our direction on the diagram moving from M10. And what we should always do is to look to see if the vector Mn falls within a triangle, because this is where the triangle law will come into play. And Mn does fall within a triangle, and I name the triangle in triangle, I'll just call it OMN, so in triangle OMN, so I'll name the triangle. We want to determine what is vector Mn. So to find Mn, we always use the triangle law. So I'm going to start with Mn, and I'm creating an equation based on the triangle law, and that equation is this. I'm going to start with M, I'm going to end with N, and I must have two of the same letters at the middle separated by an addition sign. And because we are dealing with triangle OMN, we want to ensure that these three vertices, OM and N, are shown in our equation. So we start with M, if you want to find MN, we start with M, we end with N, but the third vertex on that triangle is O, so we know O will be placed at the middle, and of course we're going to separate these two vectors, MO and ON, with an addition sign. So that is our equation created there based on the triangle law. And therefore, we know that vector MO, now this is OM, this is OM, meaning we're moving from O to M, that's the direction, but you want MO. And with vectors, when you're moving in the opposite direction, note that the sign of the magnitude changes. So the direction changes, but the sign of the magnitude changes. So it means that MO will be negative 6z plus ON, vector ON, the magnitude, it is 2x. So this here is expressing vector MN in terms of x and z. What you can do, you can write it in terms of the order of the letters of the alphabet. You can write it as 2x minus 6z. So you can state your answer like that. So that's part 1. Let's look at part 2. So part 1, part 2, find in terms of x and y in its simplest form an expression for Ln. So where's Ln? So this is Ln here. So I have L, I have N, and what I need to do is to connect by drawing a line from L to N. So let me draw a line from L to N. And because it's a vector Ln, I must put a direction, my arrow indicating the direction on my vector quantity. Now, for me to find in terms of x and y in its simplest form an expression for Ln, because I want to find vector Ln, the first thing we should do is to ensure that Ln falls within a triangle where we have the magnitudes of two vectors on that triangle. Very important. So look to see if the vector Ln falls within a triangle, and on that triangle you want to make sure you have the magnitudes of two vectors. I'm seeing Ln falls within this triangle here, which is LMN. Yeah? We just got Mn to be, let me put the magnitude on the diagram, 2x minus 6z. So we're looking at triangle LMN, so Ln falls within that triangle, but I only have the magnitude of one vector on that triangle. Ln falls within this triangle. We have OLN, so we have that triangle as well. And if we look, we're seeing the magnitudes of two vector quantities on that triangle. So once you have a triangle, the vector you need to find, it falls within a triangle where you have the magnitudes of two vector quantities. That is the triangle we're going to use. So we want to determine Ln. And how do we create our equation? We start with L, we end with N, and we make sure we have the same letters at the middle separated by an addition sign. And on this triangle, OLN, and let me name the triangle. So I'm going to start by saying in triangle OLN, so it's good to name the triangle. I want to find Ln. So I'm going to start with L, I'm going to end with N, and the third vertex on that triangle is O. So you know it's going to be O at the middle, so you'll have the two vectors LO and ON, and you separate with an addition sign. So the vector LO, and we must put that arrow on top, showing the direction of the vector. So LO plus ON, of course, will give us LN. And let's see. Vector LO, now you have vector OL, that's the direction of the vector, but you want vector LO, so it means you must move in the opposite direction, and moving in the opposite direction means the sign of the magnitude changes from positive 4y to negative 4y, plus vector ON, of course, it's going to be 2x. So the magnitude of vector Ln in terms of x and y will be negative 4y plus 2x, or you can write it in terms of the order of the letters of the alphabet. I'm going to put 2x minus 4y. Yeah? So that's the magnitude of the vector Ln. Now let's look at part B. Part B, so this was part A, 1 and 2. This was part A and part 2 part A. 2 part A. So let's look at 2 part B. They want us to show that vector AB, this is vector AB here, is equal to 2/3 into 2x minus 4y. So they want us to show that that vector AB is equal to that. So we have to show by rule that this is the result of AB. So let's do so. So I'm going to erase this information. Let me put the information on the diagram so we know what vectors we have. So Ln is 2x minus 4y. So it's important to put the information on the diagram itself. And this type of vector with letters of the alphabet as in magnitude will be known as displacement vectors. Alright? So let's erase. We can add part B. So part B, so they want us to show that vector AB. So the first thing we need to do is to connect A to B. So we have connected A to B, and I'm going to also place my arrow on the vector because all vector quantities will have direction and magnitude. So the arrow on my vector quantity. Now, for us to find AB, first thing we must do is to ensure, look to see if vector AB falls within a triangle. And we must ensure we have the magnitudes of 2 vector quantities on that triangle. So we have AB, and I see where AB falls within the triangle A and B. But do we have the magnitudes of 2 vector quantities? We do not, because this 2x minus 6y represents the magnitude of Mn. This is 2x minus 6z, sorry. Yeah, 2x minus 6z. So, for us to find vector AB which falls within the triangle A and B, and we don't have the magnitudes of 2 vectors on that triangle, but we can find the magnitudes of 2 vector quantities on this triangle because they gave us this ratio here. It says LA to AM is 1 to 2. So this is 1 to 2. Right? And what does 1 to 2 mean? It means that 1 plus 2 will give us 3, and will tell us here that vector LA is 1/3. So let me just state it here, vector LA is 1/3 of the entire vector Ln. And this is also telling us that vector AM is 2/3 of the entire vector Ln. So what we can do, we can find AM. Huh? Once we know what Lm is equal to, then AM will be 2/3 of Ln. Alright? It also says here, we don't know what MB is equal to, and we're using the triangles, we can find AM as we just saw from using that proportional relationship. And to find MB, again we have this relationship here. MB to BN is 2 to 1. It means that 2 plus 1 is 3, and MB is 2/3 of the entire vector quantity Mn, and Bn is 1/3 of the entire vector quantity Mn. So that is what that means. So when you see the ratios, make sure you know what the ratios represent. So what I'm going to do, let's find AM and let's find MB. Now, AM is 2/3 of AM is 2/3 of Ln, yeah, and we can easily find Ln because we have no information for Ln currently, but we can find Lm, and then AM will be 2/3 of that. Alright, because no information was given for Ln. So let's find Lm. So does Lm fall within a triangle where we have the magnitudes of two vector quantities, and see where Lm falls within this triangle Lnm, and we have the magnitudes of two vector quantities. We have Ln and we have Mn. I'm also seeing where Lm falls within the triangle OLM. So any of the two triangles we can use and we'll get the same result. So I'm going to use the triangle OLM because it's easier to work with those magnitudes. So in triangle OLM, I'm going to say we want to find Lm. So to find Lm, we start with L, we end with M, and the third vertex on that triangle is O. So it means that we're going to place O at the middle, separated by an addition side. So Lm is Lo plus OL. And we know that Lo, it is, we have OL, Lo will be negative 4y, plus OM is 6z. So we know that Lm is negative 4y plus 6z, and I leave it in that order because you know y comes before z. And we know that having found Lm, we know that that Am is 2/3 of Lm. So Am is 2/3 of Lm. And therefore, this will be 2/3 of Lm, which is negative 4y plus 6z. Yeah? And we know in this case that, oh shucks, I'm doing it wrong. But yeah, no, sorry. So yeah, so I'm not doing it. So we want to find Am. So that's what's my trend of this. We want to find Am. So therefore, 2/3 of negative 4y will give us what? This will give us 2/3 of negative 4y will be negative 8 all over 3y. And 2/3 of 6z, removing the brackets there, will give us plus 4z. So we know that Am is equal to, this is vector Am, which we just formed, is equal to, remove this 2 and 1, Am is negative 8 over 3y plus 4z. So we found Am. But let us also find MB. And MB is easy to find because we know MB is 2/3 of Mn. And we got Mn previously to be 2x minus 6z. So let's find MB. So MB is 2/3 of Mn. That's 2/3 of 2x minus 6z. And let us remove the brackets. So 2/3 by 2x will give us 4 over 3x. And 2/3 by negative 6z will give us negative 4z. Good? So what we have here is MB, let me remove this 1 and 2. MB is equal to 4 over 3x minus 4z. Alright, so we found MB. So now that we have AM and MB, and of course using the triangle AMB tells us to prove vector AB is equal to 2/3 into 2x minus 4y. Let us go use our triangle law to show that AB is equal to 2/3 into 2x minus 4y. So, of course, don't forget to put your directions. That's LM. So you know you'll have LA and AM moving in that direction, right? So in using, I'm going to state here in triangle AMB, right? So I'm doing the triangle based on 3 vertices. If you want to call it MBA, it's up to you. So So I'll call it A and B. Of course, we want to find AB, so we begin by writing AB. Remember, we must start with A, you're going to end with B, and we must have the same letter in the middle, and the same letter will be the third vertex on that triangle, which will be M. So this will be M placed at the middle, separating your two vectors into AM and MB, and of course, you have an addition sign to show the sum of the two vectors. Alright? And we know that AM, it is negative 8 over 3. We calculated that previously. Negative 8 over 3y plus 4z plus MB is, and of course we calculated that previously as well. If you look on the diagram, it's going to be 4 over 3x minus 4z. I'm going to put the 4 over 3x minus 4z in brackets, because once you have a sign or number, whether it's positive or negative, in front of an expression with two or more terms, you make sure you place the expression in brackets. Don't forget that. It's a positive or negative sign. Once you are going to place an expression immediately after that sign or number, and that expression has two or more terms, make sure the expression is in brackets. So this becomes what? This will be negative 8 over 3y plus 4z. Let's remove the brackets. Plus by 4 over 3x is plus 4 over 3x. And plus by negative 4z is negative 4z. And now let's simplify. So to simplify, your 4z minus 4z cancels, and you're going to be left with negative 8 over 3y plus 4 over 3x. And you can rewrite it by placing it in terms of the letters of the alphabet, order of the letters of the alphabet. This will be 4 over 3x minus 8 over 3y. But remember, I wanted in this form, this is what AB is equal to. But 4 over 3x minus 8 over 3y can be written in this form. Alright, by factorizing. So I can factorize by taking out as my common factor 2/3. So when I take out 2/3 as my common factor, and I divide 2/3 into 4 over 3 and 4 over 3x, I'm going to get 2x. And when I divide 2/3 into negative 8 over 3y, I'm going to get negative 4y. So by factorizing the expression for AB, we're going to show that AB is equal to what we have here. And we can write at the end, hence show. Alright, so very important question, ensuring that we understand the triangle law. And the triangle law is used once there's a triangle, but ensure you have the magnitudes of two vectors on this triangle. We didn't have the magnitudes of AM and MB, so now we're using the triangle A and B, so we have to find those two magnitudes, and after finding those two magnitudes, then using triangle law, we can prove that AB is equal to what we have there. Alright? Okay, so let's move on to the right, so based on the results in part 2, so this is the results we found in part 2, right? They want us to state two geometric properties relating Ln, this is Ln, and AB. So AB is, let me put it on the diagram, 2/3 into 2x minus 4y. Okay? So they want us to show a relationship between the two, and let me erase all this information I have here. Right, so they want us to, based on the results in part 2, so the results in part 2 is what we are seeing here, part 2a and part 2b. State two geometric properties related Ln and AB. So Ln is part 3. We got previously vector ln, we got previously to be 2x minus 4y. Vector AB, we got previously to be 2/3 into 2x minus 4y. So they want us to show a relationship between the two. Now we can show a proportional relationship. This is simply what? We can say here that vector AB is 2/3 of vector ln. Yeah? We see 2x minus 4y, 2x minus 4y. So if you write this, vector AB is 2/3 of vector ln. Right? ln is 2x minus 4y. If I multiply 2x minus 4y by 2/3, will give me AB, which will show that AB is 2/3 of ln. This is a proportional relationship. And this is one of the geometric properties. Or you can say, or you can say that vector ln is you can say vector ln is 3/2 of vector AB. 3/2 of vector AB. If you multiply 3/2 by 2/3, what you're going to get? You're going to get 2x minus 4y. So vector ln is 3/2 of vector AB. So it can be any one of these two. Any one of these two you can use as a proportional relationship. So multiply 3/2 by AB, it gives you ln. Or multiply 2/3 by ln, it gives you AB. Yeah, so this is showing a proportional relationship. And once that occurs, once there's a proportional relationship between these two vectors, then we can state as our second geometric property. This is our first geometric property A. Our second geometric property will be both lines AB and ln are parallel. So those two vector quantities, those two lines AB and ln, they are parallel. Once there's a proportional relationship between two vector quantities, it will prove and show that the two vector quantities are parallel. It's very, very important. Yeah, so that was part 3. All right, let's move on to the next question. So I'm going to erase. So this is a pentagon. Pentagon is a 5-sided figure. 1, 2, 3, 4, 5 sides. So I will draw the diagram. So it says here, let me put all the important information. OD is 2 times AB. OA is equal to 2 times DC. Vector OA has magnitude A, and vector AB has magnitude B. So I'm going to draw the diagram. This is the diagram I'm going to draw. So I've drawn the diagram, we've drawn it. This is A. This is A, B, C. Let me make this a bit better here. Right. A, B, C, D, O. Now, the arrows will indicate, so you have that arrow going that way, 2 double arrows, which will indicate that these two vectors, they move in the same direction and they are parallel. Similarly, if we have here, we have this arrow from OA and this arrow from B to C, those two vector quantities are parallel. Okay? So let's put the information on the diagram. the magnitude, all vector quantities will have magnitude and direction. The magnitude of vector OA is A, and of course the direction runs from O to A, which will be this dark arrow, meaning you show the direction from O to A. Vector AB, the vector from A to B, have that dark arrow there. The magnitude it is B. Now it says here that OD, this is OD, is twice AB. So if AB, the magnitude is B, then OD is 2 times B. So OB is 2B, and if OA is 2 times DC, if OA is A and OA is twice DC, it means that DC is a half of OA. Yeah, if you divide both sides by 2, these 2's will cancel out. DC is a half of OA. OA over 2 is the same as a half of OA. So DC is a half of this vector OA. So DC is a half A. So you know DC is a half A. It's important information here. So it's good to use the information given to assist you and place the information on the diagram. So don't ignore the information given, alright? Now having done that, let's look at the question. Part 1. Find in terms of A and B in its simplest form AD. Now where is AD? AD will be formed by connecting a line from A to B, and the vector of course will have direction, so you put the arrow showing you moving from A to B. And if I want to find AD in terms of A and B in its simplest form, it means that my answer must involve A and B, and AD must fall within a triangle. So let's see if AD falls within a triangle. Yes. And we must ensure that that triangle has the magnitudes of 2 vector quantities. So if you look, we have the triangle OAD, you can use that, you can name it that if you wish, and we have the magnitude of vector OA and the magnitude of vector OD. So we can use that triangle to help us to find AD. So I'm going to say in triangle OAD, how we set up our equation? We start with vector AD. And remember, we begin with A, we end with D, and the third vertex on that triangle is O. So we know O has to be placed at the middle. So I'll have A, I'll have D, and I'll place O in the middle, O being the third vertex on that triangle, separated by an addition sign, and of course I'll put my arrows on top of my vector quantities. Yeah? I want to make sure you understand that important rule. And what is AO? You have OA, that's the direction from O to A. So AO means you're moving in the opposite direction, so the sign of the magnitude changes to negative A. Plus, OD, like OD you're moving from O to D, so you write 2B. So the magnitude of AD is negative A plus 2B. So we'll talk part 1. Let's do part 2. So I wanted to find here BC. Where is BC? This is BC here, right? So I'll put the direction from B to C. Now BC doesn't fall within a triangle. You see that? So there's not AD. It's always good to put the magnitude on the diagram, right? Don't forget that. As soon as you get the magnitude, put it on the diagram one time. Now BC doesn't fall within a triangle. No. I mean, you can create a triangle by drawing a line from B to D. You can do that. So you can find BD and then use that to find BC. So that's one approach you can use. But you can also use what I call the polygon law. The polygon is a figure with many sides, right? Starting from a triangle, quadrilateral, four-sided figure, and so on and so forth. So this here is a quadrilateral, and we can use the You can use the polygon law, you know, to find it, to find BC. Yeah? If you want to use the entire polygon here, because you have the magnitudes of AB, OA, OD, BC, so you can use that, or you can use this quadrilateral here. It's up to you. So I'll go to quadrilateral. So I'm going to say in quadrilateral, right? I'm going to name it A, B, C, D. Good? Because I want to find BC, I'm going to start with B. I'm moving all the way around to C. So I'm going to start with B. I'm going to, of course, if I want to go all the way around to C, it's going to be BA plus AD plus DC. You realize the middle letters here are the same, the middle letters here are the same. So I'm saying BA plus AD plus DC. This is what you call the polygon law. Right? If you wanted to use the entire pentagon too, you could have. Because you have the magnitudes of all the vectors on that pentagon, which can help you to find BC. Same with the quadrilateral, we have the magnitudes of those vectors to help us to find BC. So let's go work it out. So this will be BA, you have AB. So BA means you're moving in the opposite direction, that's a negative B. Plus AD is negative A plus 2B, and I'm going to put negative A plus 2B in brackets, because when you have an addition or subtraction sign, and immediately after you have an expression with two or more terms, you make sure you place that expression in brackets. Plus DC is a half A. So let's simplify that. This will be negative B, I'm removing brackets. A plus by A minus is a minus A. A plus by A plus is a plus 2B plus a half A. And what I'm going to do now is just group like terms. This is negative B plus 2B and negative A plus a half A. And negative B plus 2B, negative 1B plus 2B is positive B. And negative a half A plus a half A is a negative 1 plus a half is negative a half A. And if you want to write it in order of the letters of the alphabet, this is negative a half A plus B. And this is the answer for BC in terms of A and B. So using the quadrilateral, which is known as the polygon law, or you could have, and of course getting familiar with the triangle law. Yeah? Alright, so let's move on to the next part of this question. And let me put the information on the diagram. So BC is a half A, negative a half A plus B. So it's always important to put the information on the diagram. Alright? Now, the third part of this question. State the conclusion about AD and BC. So this is the two parallel lines in a vector question. Two parallel lines on either side of the vector quantity simply means what's the magnitudes, right? The magnitude of AB and BC. State the conclusion about. So I'm going to erase here, drawn in 1 and 2. So this is what we have here for 1 and 2. So I'll erase part 3. So part 3, we know that AD is negative A plus 2B, and we know that BC is negative a half A plus B. So what kind of relationship can be established between those two vectors? Let's see if there's a proportional relationship that we can establish. So we can say here that vector BC, we can write it this way, is a half of vector AB. Vector BC is a half of vector AD. So if you find a half of negative A plus 2B, you're going to get this. So BC is a half of AD. Or you can say AD, vector AD is 2 times vector BC. So 2 times vector BC. If you multiply BC by 2, so 2 by negative a half will give you negative a A, and 2 by B will give you 2B. So you can write it either way, showing that there is a proportional relationship. Alright? Which will prove, so a proportional relationship that vector BC and vector AD are parallel. Alright, so you're going to show 2 vectors are parallel. You want to show that there is some proportion existing between 2 vectors. Alright? So that's it for that question. Alright, let's move on to another. So what we did previously, these questions where you have the magnitudes, which are letters of the alphabet, you call them displacement vectors. And now let's look at position vectors. That's the other type of vector question you can see, right? So let's look at this question. So the 2 types of vector questions you can encounter, and the same triangle law, polygon law, all the laws that you have to know will come into play, right? So the following vectors are defined as shown. You have Wx. Vector Wx has magnitude 5, negative 1. So this is the magnitude in terms of column vectors and this, right? A column vector always looks like this. Good? So you know you deal with position vectors. Alright? And you have here vector xy has magnitude negative 3, 7. And zy, vector zy, has magnitude 8, negative 7. Determine each of the following. One, a vector other than 5, negative 1 that is parallel to Wx. So let's have a vector other than 5, negative 1 that is parallel to Wx. So part 1, a vector that's parallel to Wx could be a vector with magnitude 10, negative 2. Right? It means that this vector quantity and this vector quantity will be twice that vector quantity. Yeah? So if I multiply 5, negative 1 by 2, I'm going to get 10, negative 2, which shows that there's a proportional relationship. Yeah? So a vector other than 5, negative 1 that is parallel to Wz, right? If you want to call it vector, anything you want to call it, Wx, xy, yz, if you want to say AB, vector AB, you can call it 10, negative 2, which will be parallel to Wx. And why it's parallel? Because you can say here that vector AB is twice vector Wx. Multiply vector Wx 5, negative 1 by 2, you get 10, negative 2, which is AB, which proves that they are parallel, right? So therefore, AB is parallel to Wx. So you can use 10, negative 2, you can use 15, negative 3, if you want to use that also. Yeah? Once there is a proportional relationship between the 2 vectors. Right? That's part 1. Let's look at part 2. So we have Wy. Now, what I always advise with vectors, first to find wy. Again, with position vectors, it's always good to have that visual. You can work it out based on the vector quantities we have here. You can work it out, but it's always good to have a visual. And I'll just set up a quick diagram with the vector quantities we have there, so we have a visual. But we can work it out without the diagram. So look at the visual. Position vectors. Y-axis. We have x-axis. This is 0. We have 1, 2, 3, 4, 5, 6, 7, 8. We have -1, -2, -3, -4. We have 1. We have to draw this a bit lower. Let me draw this lower. So let's have a visual of it, right? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5. 1, 2, 3, 4, 5, 6, 7. And we have -1, -2, -3, -4, -5, -6, -7. So like I said, I don't need this diagram, but I want you to have a visual. So Wx is 5, -1. What is 5, -1? 5, -1. 5 is x, -1 is y. From the origin, that's why it's a position vector. You're moving 5 to the right because it's positive. 1, 2, 3, 4, 5. And -1 means you're moving 1 downwards. Right? So we can put, if you want to put all right, we want to put W. Right, so I'll put this as W X, right? So this is my position vector. This is my vector Wx. XY is -3, 7. -3 means you're moving 3 to the left and 7 upwards. Let's have a visual, alright? So you're moving 3 to the left, 1, 2, 3, and 7 upwards. 1, 2, 3, 4, 5, 6, 7. This will be Y. So you're moving 3 to the left because it's -3, 1, 2, 3, and 7 upwards. So 1, 2, 3 from X and 7 upwards. And you have next, you have ZY. ZY, of course, if it's ZY, see that you have Y, you don't have Z. What we should do is show what is YZ. So YZ will be the inverse of ZY, and the inverse of ZY means that will be -8. So I'll put here, this is XY. Let's show you visual. So because you want ZY, you have Y, you have Z. To get ZY, what we should do is, of course, find YZ first. Because we have Y, we need to find Z. what you need to do is find yz first, which is the reverse of zy. Or the inverse of zy, which will be negative 8, positive 7. So that's yz. Negative 8, positive 7. So it's going to be negative 8 moving to the left. 1, 2, 3, 4, 5, 6, 7, 8. And positive 7, moving 7 upwards. This is 1, 8, 9. Let me move this. 10, 11, 12, 13, 14. So this will be 7 upwards. 1, 2, 3, 4, 5, 6, 7. Alright, so that will be z. So zy is, if you move, if you want 8, negative 7, if you move 8 to the right and 7 downwards, you're going to arrive at zy, which is 8, negative 7. So this right here is zy. So if you want to get zy, you didn't have z previously. So because they have zy and they gave you y here, we found y, then what we should do is find yz to help us to locate z, do the reverse. And having found z, then of course zy means you're moving 8 to the right and 7 downwards towards y. So this is zy here. Now this is just a visual, right? So we don't need to do all this. I'm just showing you a visual of placing these vector quantities, position vector quantities on a diagram. Right, allowing W to start from the origin, so I'll found Wx 5, negative 1, then xy, negative 3, 7, and then zy, finding yz first, negative 8, 7. So you know zy will be 8, negative 7. Alright, so this is zy here. So that's a visual. But forget it. Let us now move on to part 2 to find wy simply. We start with w, we end with y. Good? And make sure you have the same two letters at the middle, which will be your x's. Wx, xy will give you wy. Straightforward. So wx, it is 5, negative 1, plus xy, it is negative 3, 7. And therefore, when we work it out, we're going to get 5 plus negative 3 in brackets, negative 1 plus 7, which will give us 8 plus 5 minus is 8 minus 5 minus 3 is 2, negative 1 plus 7 is 6. So this is wy. Right, so wy, if I connect w to y, this will be 2 and 6. And here you're right, move 2 to the right, 6 upwards. So a visual is always important. If I count 1, 2 to the right, and then 6 upwards. 1, 2, 3, 4, 5, 6. Good? So that's wy. And 3, xz. Of course, you don't have to do this in the exam, but it's a visual to help you. Xz will be begin with x, end with z, and you want the same letters at the middle. So, begin with x, end with z. But we want the same letters at the middle, so it's going to be xy and yz. So, xy and yz separated by an addition sign. So keeping in mind, xy is negative 3, 7 plus yz. Now they gave us zy initially, but yz of course means you're moving in the opposite direction and the sign of the magnitude changes. So therefore, this is positive 8, it's going to change to negative 8, and this is negative 7, it's going to change to positive 7. So YZ is negative 8, 7. When we work that out, we're going to get what? Negative 3 plus negative 8 in brackets. And we're going to get 7 plus 7. Which is a plus by minus is a minus. Negative 3 subtract 8 is negative 11. 14 will be XZ. And we can test it out. This is XZ here. Right? X, if I draw a line from X all the way to Z, remember it's negative 11, 14. So this is what? Negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. And then 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So XZ is negative 11, 14. So you see, XY is the movement of the vector. Negative X means you move to the left, positive X means you move to the right, positive Y you move upwards, negative Y you move downwards. Alright? So let's have a visual to show you that the answers we obtain here are right. Okay? Alright, let's move on to the next. So we have now this is part 4, which is the modulus of xy. So let me erase here.